Alright, so the problem that I missed the most points on was on problem number one. And what we have to do on the first question is we have to write down three energy conservation loop rules for this circuit. And what we have to do is we're going to have to find the loop one, which will be going through the current, going through the EMF in bulb one, and loop two, which will be going through the EMF in bulb two, and the capacitor. It includes a capacitor for both loop 1 and loop 2, and loop 3 would be the loop that's between the bulb 1 and bulb 2. So loop 1 would be 2 EMF minus voltage of the capacitor minus I1R. Loop 2 would be 2 EMF minus voltage of the capacitor minus I2R. Loop 3 would be I2R minus I1R, which is equal to 0. Then voltage of the capacitor would equal to 2 EMF minus I1R, which is equal to 2 EMF minus I2R. That's how we derived I1R equals I2R. And the node rule would consist of the I of the capacitor would equal to I1 plus I2 because it combines. It's a series, it's a parallel circuit. The current will separate. Then determine the initial currents passing through each bulb. So how you do that is that the capacitor itself won't be fully charged, so you basically ignore the capacitor's existence. So it would be 2 EMF minus Q over C minus I1R equals 0, but completely cross out the Q because there isn't a charge yet because it's immediately after the current has been hooked up to the battery. So it's I1R equals 0. Then you apply the same principle to the second bulb. So it would be 2 EMF minus I2R equals 0. So 2 EMF equals I1R, and 2 EMF equals I2R. So essentially I1 and I2 is the same because resistance is the same, so which proves that the third loop rule is correct. Then determine the current passing through each bulb after the switch has been closed. Well, there is no current running through the bulb anymore because the switch has been closed for a long time. So the potential difference would eventually run out, which means that I1 and I2 will eventually equal to 0. Then how you figure out the final charge itself is that because no more current is running through, you basically eliminate the current equation from the loop rule. So it would be 2 EMF Q1C QC, there, and 2 EMF minus Q divided by C I2R. So it's the same thing. So the final current running through would be 2 EMF, a final charge running through would be 2 EMF times C equals Q, and this would be a logarithmic function.